Good morning, good afternoon to all of you from around the world. While we're waiting, just feel free to introduce yourself on the chat stream. Tell us who you are and which organization you're coming from. My name is Dr. Esther Tan. I'm in charge of the public health section of DHMOSH. DHMOSH stands for Division of Healthcare Management on Occupational Safety and Health here at the United Nations headquarters. Today, we have the privilege of hosting Dr. Alexandra Touroutoglou. She's the Assistant Professor of Neurology at Harvard Medical School. She leads clinical trials to develop new treatments for patients with Alzheimer's disease at the Massachusetts General Hospital in Boston. She's currently the Director of Imaging Operations at the Massachusetts General Hospital Center for Translational Brain Mapping. She is a real expert and rock star, and we're so happy to have her with us. She's been awarded numerous grants from the National Institutes of Health. She's the author of highly cited articles in Aging and Alzheimer's Disease. Her clinical trials use innovative techniques to understand how brain shrinkage leads to symptoms in Alzheimer's disease and how brain stimulation can alleviate these symptoms in people who are at early stage of the disease. Her goal is to intervene at an early stage so that people have the best chance of being treated successfully. And her team has recently discovered a remarkable group of older adults called Superaters who defy the inevitable outcome and continue to have young and youthful brains despite their age. She's known internationally for her clinical research, having contributed to widely regarded textbooks in aging and dementia, and she has won several awards for her work and her findings, and she's been featured in the Harvard Gazette, the BBC, and the New York Times. So without further ado, I'd love to hand over the talk to Dr. Alexandra. We will have about 40 minutes of presentation, and then we will end with some conversations and questions that you might have about her talk. And just feel free to also just put in any questions in the chat stream as well. So I will now hand over to Dr. Alexandra. Thank you so much.
Good morning or good afternoon, depending on where you're joining us around the world. It is a great honor and a pleasure to be here at the United Nations. I would like to thank Dr. Esther Tan and her team for inviting me and congratulate them for the excellent job done in organizing and hosting the United Nations Public Health Conversation Series. I'm Assistant Professor of Neurology at Harvard Medical School. I run clinical trials at Mass General Hospital with the focus to translate findings from healthy aging to benefit for patients. Today, I'd like to discuss with you an interesting phenomenon we have been studying with my colleagues at Harvard Medical School. So, as we age, there's a certain amount of atrophy that is happening in our brains. It is not enough to be pathological, but it does affect our cognitive abilities. And what we observed in older adults that we are studying, when we measure the level of brain atrophy, brain shrinkage over decades, we see that almost all elderly present atrophy in their brain, except for an elite group that we call superagers. And now you might be thinking, what is a superager and how I can be one? So here we are going to review our studies with these remarkable super sharp superagers, and let's try to uncover their secrets. Before I talk more about superagers who somehow managed to defy the inevitable, having brains that really refuse to age, let me give you a brief background on normal aging, typical aging, and its effects on memory and the brain. We all know this. It's common for memory to decline as people age. And you see this over decade, there's a decline in memory performance. So looking at this average data in isolation, we might come up with the conclusion that memory decline is an inevitable consequence of aging. But of course, this is only what happens on average. I'm taking here some advice from Hippocrates, who said, it is really important to look at individual differences. So now, let's take another look at the same graph with a closer examination of individual differences represented here with the data points. If I can direct your attention to these individual data points on the right that I have circled, you will notice that some older adults show memory capacities really rivaling those of young adults. So now I'm going to say that memory decline may be common, but not inevitable. Some older adults actually perform as well as young people on memory. In the lab, we define superagers as older adults around or just after retirement age, mostly their 70s and 80s, who can remember as well as people in their 20s. We give them a memory test with a list of 16 unrelated words, and they are asked to recall these words 30 minutes later. An average 50-year-old will remember 9 words. The average 80-year-old will remember about 5. Superaters remember them all, like young adults. You're probably wondering, what does a superager look like? And we have investigated this, and I can tell you that superaters come from all walks of life. We have identified superaters of both genders and with a wide range of educational backgrounds. So if it is not coming from their histories or backgrounds, what is it that makes superagers special and super sharp? The first thing we wanted to do is to put them in an MRI scanner and look into their brains. Before I show you how a superager brain looks like, let me show you how the brain of a healthy, typical older adult looks like when compared to an average young adult in an MRI scan. On the left image, there's the brain of a young adult, of one young adult 25 years old. And on the right image, there's the brain of a healthy, typical older adult, 75 years old. As you can see on the right image, there is a typical age-related atrophy, which is normal. It's happening in normal aging, observed in many brain regions, shown here with white arrows. For example, in the hippocampus, prefrontal cortex, the insula, and the cingulate cortex. And here we quantify this brain atrophy, where we had a group of older adults and we compare them with a group of young adults. As you can see here, all the yellow spots are areas in the brain where healthy, typical older adults have atrophy compared to young adults. There is normal age-related atrophy in both the right and the left hemisphere of the brain. So it is a pretty widespread aging effect. Now look at the brains of superagers compared to young adults. You see that there are no yellow spots at all. Remarkably, the brains are truly youthful. And when I say youthful, I mean statistically indistinguishable from young adults. If you were to present me with 2 brains in MRI scans, one from a young adult and one from the superager, I wouldn't be able to tell you which is which. Here are 2 individual brains. You can see on the right that the superager has really maintained a brain with youthful characteristics. So what we're looking here is a 25-year-old brain in a 75-year-old body. So what does it take to be a superager? In one sentence, I would say a youthful brain in someone who is 65 years old or older. And there are multiple ways to define a youthful brain, and I will briefly review our superaging work now to show you how superagers meet all these definitions. From the beginning, we were very interested in pinpointing what was neurologically different about these individuals. This led to our first imaging study of superagers, looking at their brain anatomy. Using a standard MRI, our team discovered that superagers had no brain atrophy compared to their peers that had average brain power in a number of brain regions. While the cortex, the outermost layer of brain cells that is critical for many thinking abilities, and other parts of the brain typically shrink with aging, in the brains of superagers, a number of those regions were comparable in size to those of young adults. If we look more closely at these regions, we see that there are brain regions that are important for cognition. We group them based on their function, and you can see here the regions in blue indicate brain regions that are important for attention, and those in yellow are regions that are important for memory. We also found that superagers had a larger hippocampus, and we know that the hippocampus is important for memory function, important for forming and storing and processing memories. I've included here MRI scans at the level of the long axis of the hippocampus. Look at the hippocampus at the superaging brain on the left. These images illustrate that superagers had larger hippocampal volume, shown here in green, compared to typical older adults, as you can see here in red. So now we know that superagers have greater brain volume in a number of brain regions that are important for cognition. But that in itself doesn't necessarily explain the sharp memory. To explain that, we had to show that the size of brain regions predicted their memory performance, as we show here. Looking at the individual brains, one of the strongest relationships between brain size and memory was found in the hippocampus. In this scatter plot, you see that the individual who had the largest hippocampal volume performed among the best in memory. And this individual who had the smallest hippocampal volume performed among the worst in memory. So the answer is yes. Not only superagers had no shrinkage in their brains, but also the size of the superaging regions, brain regions, was related to their memory abilities. The hippocampus was one of the first places we looked at. We were expecting to see a healthier hippocampus in superagers because it has been known for years that this brain region is crucially important for memory. What was surprising and interesting to us was that we also found that the frontal portion of the brain, known as the mid-cingulate cortex, shown here on the image on the right, was also a key superaging region. And you can see from the bar graph here, which I've included just to show you, to highlight this important brain region. The gray matter thickness, the size of this brain region, is the same in superagers as in the brain of young adults. And here is what is interesting about that. This region, the mid-cingulate cortex, is not a traditionally memory region. It is involved in attention, integrating information from different parts of the brain. And it has been also described by some to be the brain basis for tenacity and persistence in the face of challenges. So being a superager then might be about more than having greater cognitive ability. It might also depend on your willingness to exert effort and be really tenacious when faced with difficult tasks and challenges. So early on, we saw that the brain scans showed that superagers avoid brain shrinkage in particular regions. But the structure of the brain is not the whole story. No brain region is an island. Brain regions constantly communicate with each other. They are organized into groups or networks that communicate with each other with synaptic connections. Research has shown that these synaptic connections are typically disrupted in normal aging. And so in our second study, we asked the question, how well connected are the brains in superagers? In this study, we used an innovative MRI technique and found that superagers not only had significantly stronger brain connections compared to their peers, but they were also statistically indistinguishable from young adults. So now the question is, if this better connectivity can further explain their sharp memory. To answer this question, we looked at the individual brains as we did previously with the anatomy. Here you see that hippocampal connectivity to another region of the memory circuit known as posterior cingulate cortex here was significantly stronger in superagers compared to typical older adults. And the stronger the communication between these two regions, the better the performance in memory. So the answer is yes. The better brain connectivity can explain superior memory in superagers. Next, we wanted to look closer and better understand what was going on in the brains of superagers, how they are activating when the brain, when they are doing a memory task, when they are learning and remembering. So we gave them a memory task with pictures of objects and scenes and watched their brains in real time to see which parts are activating using functional MRI. This technique, functional MRI, fMRI, is widely available, and it has been discovered at our center in 1991 at Mass General. And it's almost like acquiring a little movie of brain thinking. So we put participants in the scanner and paid close attention to their visual cortex. When you see scenes, your visual cortex activates brain regions specific to scenes. And when you see objects, your visual cortex activates specific regions, brain regions specific to objects. Young people are better at creating this specific brain activity than older people typically are. And this selective brain activation suggests higher efficiency in processing of information. We watch what happens in their visual cortex as they remembered pictures, and that's what we found. We found that superagers maintained youthful brain activity represented here by these triangles. They had the same high level of neural efficiency as young adults. I mean, these triangles look a lot like each other. This pattern of brain activity allowed them to create strong memories of the pictures they saw. In the typical older adults, on the other hand, this selective activity is reduced. You can see that in the triangle showing a blurred pattern of brain activation. We are very excited about these findings because they have the potential to point to a possible mechanism behind superior memory. So everything I show you so far were studies that were performed in the laboratory. But outside the laboratory, we know that often unexpected health events happen, and in these events can accelerate cognitive decline. An interesting question is whether superagers are more resilient to the kind of real world stressors that can contribute to dementia. For example, do they avoid other aspects of physiological decline and diseases of aging? So that brought us to our most recent study, where we focused on one such health event, surgery, which can be a major stressor for the body and the brain. We showed that even when faced with a stressor like that, superagers appear to be more resilient to developing a condition such as postoperative delirium after surgery. Delirium is a confusion state. It is one of the most common postoperative complications in older adults. It affects as much as 50% of patients 65 years old or older, and it is substantially increasing the risk of death, prolonged hospitalization, and long-term dementia. What we found in our study was that none of the superagers demonstrated clinical delirium after surgery. What that means is that superaging may confirm the real-world benefit of resilience to complications after surgery, which is, in this case, it was delirium. To summarize our superaging work, early on, when we looked at the neuroanatomy of their brains, scans showed that superagers avoid brain shrinkage that typically comes with normal aging, and that their brains look decades younger. We've also established that superagers don't just show preserved brain structure. When we looked at how their brains are connected and networked, we observed that the brains in superagers are much more connected. Their brain connections and communications between their neurons are as strong as in the young brains. And we also saw that their brain function is more efficient than their peers that typically have average brain power. And it is not just memory. Superagers, we found that may have built-in protection against two other stressors as well, such as delirium after surgery. So we're getting closer to understanding what makes superagers special, but I'm sure you still have many unanswered questions. And indeed, there are many unknowns about superagers. You might wonder by now why superagers continue to have youthful characteristics in their brains and youthful brain power. Why is it that one person's brain grows so much thinner with age, whereas another stays exactly the same with age? We and others have been exploring several theories to explain this. It's possible that superagers are superagers from birth, and that they start out in life with thicker, stronger brains. Another theory is that perhaps their brains somehow change over time to compensate for aging damaging effects. Almost certainly, it's a mix of both, good genes and environment. Both allow superagers to resist the age-related cognitive decline and the age-related decline in brain power. It has been suggested that having resilient memory during aging could be inherited, and that a particular gene might be associated with superagers. For example, specific genetic variants of the MAP2K3 gene have been previously linked with this group of superagers. So part of the difference between superagers and typical older adults might be genetic. It is also possible that a more complex and enriched environment might contribute to the phenomenon of superaging. Superagers, for example, have been reported to have more friends and family connections, so social factors also matter. And there are probably numerous other factors that we have not yet discovered. So to conclude our discussion on these super sharp superagers, I thought I'd let the superagers speak for themselves. This area of research has attracted a lot of attention worldwide and has been the focus of several pieces from the media, including this one from BBC. It features superagers giving us advice on how to stay young. I think you will see from this that it is as much about your attitude towards aging as it is your brain health.
Don't lose interest in life. Just keep busy and keep moving.
You need to find something that you love that makes you feel curious and alive.
It's a number to me. I feel much younger. I started exercising very young. And when I say young, in my 50s.
I just think that I can accomplish wonders. I like to do things. I don't want to sit in the background. I'm an optimist first and foremost.
Have variety in your life. Enjoy what you're doing.
Enjoy being challenged.
Don't take anything for granted, including your own body. Make new friends, try new things, live the life you love, and love the life you need. Just keep your mind open and be as argumentative as you want to be. Feel like I'm the last one standing.
When we meet older adults, a common question we get is, how can I make myself a superater? And how can I prevent cognitive decline that happens in normal aging? And in this day and age, probably the biggest question they ask is, how can I prevent myself from developing dementia like Alzheimer's disease? And this is where studies of superagers can help. It is interesting to study the superaging phenomenon on its own, but there are also things we can learn from this elite group that are relevant to Alzheimer's disease. These exceptional individuals can really teach us ways to help us prevent Alzheimer's disease. For example, superagers somehow manage to not develop the symptoms of Alzheimer's disease, even though they show the pathology that is thought to lead to the disease. Let me explain what I mean by that. It is generally accepted in the scientific community that in people with Alzheimer's disease, the brain is marked by a large accumulation of plaques, which are made of a protein called amyloid. Recent studies have shown that superagers and their peers appear to have similar levels of these amyloid plaques in their brains, yet they do not show the memory decline. So this suggests that superagers may be resilient to dementia and Alzheimer's disease. It also shows that we can use what we learn from superagers to help others reduce the risk of Alzheimer's disease. Superagers can also inform our strategies to develop effective treatments for Alzheimer's disease and related dementias. So with the rest of this talk, I will show you an example of such a treatment that we have been recently developing, which was inspired by superagers. So one of the things we learned from superagers is that the size and the connectivity of the hippocampus predicts their sharp memory. As we saw earlier, the hippocampal volume is fully preserved in superagers. It becomes somewhat smaller in normal aging, but it is markedly smaller than normal in a person with Alzheimer's disease. There are studies that have been done to show that in normal aging, you can improve the function of the hippocampus with non-invasive brain stimulation and make the typical older adults to be closer to the levels of superagers. So now the question is, how can we translate that to the Alzheimer's disease world and try to improve the function of the hippocampus and make patients a bit closer to normal, to typical older adults? This is the question that inspired us to design a clinical trial that targets neuroplasticity, which is the ability of the brain to form new synaptic connections. We have a clinical trial going on right now at Mass General where we are using this innovative technique with non-invasive brain stimulation to induce neuroplasticity in the hippocampus and other regions, other brain regions of the memory circuit to target Alzheimer's disease. The hope is that by inducing neuroplasticity, we will improve the function of brain regions that are important for memory. And by strengthening the function of these brain regions, we expect to see improvement in memory symptoms. We are focusing on people who are at an early stage of the disease. Our goal is to intervene at this early stage, at an early stage, so that people may have the best chance of being treated successfully. Let me share with you the results from our first patient. This is a patient with Alzheimer's disease who couldn't remember words. As you can see, the patient showed an improvement in his ability to remember words after stimulation, shown here in red, but not after placebo, which is the absence of stimulation, shown here in blue. And here's how the stimulation affected his brain function. When the patient came to the clinic early on, communication between regions in his brain looked weak. We found that after stimulation, communication between brain regions became stronger by almost 40% relative to baseline and compared to placebo. These results are preliminary, coming from one patient, albeit very encouraging, suggesting plasticity effects after stimulation. Our trial is ongoing as we're trying to better understand the efficacy of this treatment. But I hope I show you today the potential to use findings from Superaters and healthy aging and translate them for direct benefits for patients with Alzheimer's disease. To wrap up, taking together, our findings show that studying Superaters is an alternative approach to study Alzheimer's disease. Instead of studying what has gone wrong, we study what the other side of the coin, what has gone exceptionally well. We're studying the whole spectrum from the diseased brains to the brains that refuse to age. I'd like to leave you today with the knowledge that for some older adults, age-related cognitive decline is not inevitable. Having a super sharp, a youth brain is possible in older age, and dementia is not inevitable either. Superaters can offer clues towards the secret of the sharp memory, and if we can understand what makes superagers special and continue to have youthful memory abilities despite their age, we believe that's the first step towards understanding successful aging. We hope that our superaging work will promote more research to understand how to prevent decline in memory that accompanies aging in most of us, how to be resilient to Alzheimer's disease, and ultimately lead to better interventions and treatments for Alzheimer's disease. Before I finish, let's hear from one superager from my native country, Greece. Sophocles, the famous Greek dramatist, he notes the existence of successful agers with this line he wrote at the age of 92. «Και γάρι γέρον εγώ, το τις δε χειρός, ου γεγερέκεν στένος». What if I have aged? My strength has not aged yet. With that, I'd like to thank our participants, patients, and their families for their participation in our studies. My colleagues at Mass General and Harvard, who are my co-authors, Brad Dickerson, Lisa Felmer-Barrett, Joseph Andriano, Bonnie Wong, Yuda Katsumi, and Mark Aldive, all my other collaborators and funding agencies, and I would like to thank you all for your attention. Thank you.
Thank you so much, Dr. Alexandra. That was really, really interesting. I really want to be a superager after your talk. So let's go into a couple of questions. We have about 15, 20 minutes of questions. Maybe just to start, just kind of based on your study, are you able to extrapolate what percentage of the population are like superages?
We cannot hear her.
Right. Okay. So it's not, we believe that superagers is a rare phenomenon. It's not very common. We don't know for certain, we don't have an accurate estimate as to how many superagers are there. We know that superagers have always been there. but we really need epidemiological multi-site studies in the US and around the world to show us that more precisely how rare this group is. But we do think that we believe it's a rare phenomenon.
Okay, so it's more rare than common.
Yes.
And then my next question relates to, many of us probably know people or loved ones with dementia and suffering from memory losses. When is it kind of normal forgetting things versus something like more serious like Alzheimer's or dementia?
So forgetting is a normal part of, we have to start with that forgetting is a normal age-related cognitive decline, and forgetting is a normal part of aging. It's a part of normal aging. Questions that come to mind are, for example, you go into one room and you ask, why did I come into that room? I can't find this word. Where did I place my keys? What did I want to say? This type of questions are really, if you are part of the normal aging, and if you can trigger your memory with a reminder, or if you can trace your steps, then that's more likely to be a normal forgetting. When people have mild problems, then we ask the question, how frequently did you forget paying your bills? How frequent did you forget your appointments? How frequently did you misplace things? These are more notable problems that are observed in mild cognitive impairment, but still a person will still be able to live independently. And then when the disease progresses and becomes to a point where someone has dementia, then forgetting is not mild anymore. And someone with Alzheimer's disease can no longer live independently. And a person with Alzheimer's disease will have trouble remembering from minute to minute, and sometimes from second to second. You would ask your spouse, where are we going today? And then after a second, you will ask, where are we going today? So it is the severity of the complaints, of the symptoms, of the memory, of the forgetting, the memory problems, and how that affects your independence, your ability to live independently in community and at home, how really it affects your quality of life. That's the dividing line.
Great, thank you so much. I'm seeing on the chat that a lot of people are interested in really how can we stimulate ourselves to be a super ager. So, what are some of the evidence kind of based interventions that we can make to really improve our memory, expand our hippocampus and all that you said? Can you share some potential intervention that we can do on ourselves to become super agers?
That's a very common question. Thank you. So we and other neuroscientists and researchers are really actively investigating treatments for dementia. But the best possible solution is to prevent the disease altogether. When nerve cells die, we don't have currently a way to rejuvenate them. So if we can intervene early on, it is possible, we might be able to prevent that process. And we're making good progress, really good progress. But until we get there, I would say the most powerful way to protect our brain health is to live a healthy life. There was a recent report with a committee that was formed by a committee of experts in the US and around the world that looked at the most rigorous, up-to-date research on our ways how to prevent dementia, how to prevent cognitive decline, or even reverse cognitive decline, how to take care of our brain, and how to maintain brain health. So they came up with they found there was encouraging evidence for 3 types of interventions. One intervention is cognitive training, meaning staying mentally active. Cognitive training includes programs aimed at enhancing problem solving, reasoning, memory, speed of processing. We're talking here about a structured training program that could be computer-based or not. And here it's not the same thing as computer-based. I want to clarify that it's not the same as computer-based brain games. Computer-based brain games it's not about sitting by yourself in front of a computer. Actually, there is no evidence showing that computer-based brain games make a difference. Here it is more complicated and more structured. And there are also other activities that we can do to keep our brain active, like reading, learning a new skill, taking up a new hobby, socializing, meeting with friends, interacting with people. That requires a lot of behaviors that are really using memory and training our memory and problem solving. And all these activities help us being mentally active, which is really important. When your brain is mentally active, your brain cells fire vigorously. And when they do that, they create new connections. And the greater the number we have and the stronger new connections we have, think about it as the greater reserve backup cells we have when Alzheimer's disease might form. So it is really important to keep our brain active.
Just as a follow-up to that, I'm just wondering if there are studies being done, given that you have identified a pool of superagers, that you can go back and look and see, from childhood until now, kind of what has been their activity pattern like, what's their social environment like? Is there something like that where you retrospectively go back and kind of look at these people's lifestyle?
Because Superaters is a recent phenomenon, it's not a recent phenomenon, it's a rare phenomenon, but we started this research relatively recently in 2016. We don't have a way currently to go back and see what they were doing in childhood or adulthood or when they were young. But we do know from other studies that, for example, cognitive training can really increase our regions that are strengthen the regions that are important for superagers that we talked earlier today. For example, it has been shown that cognitive training can enhance this specific brain activity pattern that we saw earlier in the visual cortex of superagers. By doing that, you can train your visual cortex to be more efficient.
Sorry, go ahead. Yes.
I was going to follow up about two more interventions that I think that are really important. One another intervention is the intervention that controls high blood pressure. This is particularly important for people with hypertension. High blood pressure has harmful effects for the brain, for the body, for the blood cells, and for the blood vessels. And by lowering high blood pressure, we can also lower, our risk for vascular dementia and for stroke. I'd like to know that this needs to be done in the middle age, because this is when brain changes occur in our life. And then a third intervention that the committee identify is physical exercise. For example, keeping physically active. For example, aerobic activity or strengthening training. And here we don't talk about, you don't have to be a marathon runner to reap the benefits of exercise. It doesn't need to be that you have to start a gym. It just needs to doing more than you currently do. You can start by walking. It has been shown in clinical trials, which is the medical proof, which is the gold standard of medical proof, that that training can induce cognitive benefits over a short time. Training over a short time can increase our cognitive performance, so induce cognitive benefits, and also induce changes in the brain. It has been shown that it induces a nerve cell growth that strengthens the regions that are important for that target Alzheimer's disease. And also it can trigger the breakdown of toxic proteins that are found in Alzheimer's disease. And more recently, I came up with a study that showed that in older adults, 6-month training increased the thickness, the volume, the size of the mid-cingulate cortex that we saw earlier in the talk. It is a really important key superaging region.
I have a question about yoga. Does yoga help as well? I mean, I assume any sort of physical activity and movement is helpful.
Yes, any activity that speed up your heart and breathing that helps you, any kind of moderate intensity activity, 30 minutes in most of the days is helpful.
I have a question in the chat about the kind of characteristics of the superagers with regards to race, socioeconomic. Was there anything that you saw or specific age band or? Yeah.
Currently, we were looking into that more closely, but I can tell you that they come from all walks of life. There was no gender differences between typical older adults and superagers, no differences in their educational backgrounds.
One interesting question came up in the chat, whether having children predispose you more to being a superager or not. I assume that it's kind of, you didn't identify any of that relationship.
No, we haven't looked at that specifically, but I would predict that having children making you deal with complex problems every day might help you being more mentally active and might help your brain health. But no, we don't know if there's any relationship between having children and being superager. We recently got funding from the National Institute of Aging to look at all of these questions about more closely about the characteristics of superagers, what they're doing in daily life, how they exercise, what they're eating, and what is it that they're doing outside of the laboratory.
Another question relates to kind of diet and food, because I mean, for example, I notice myself, if I eat like too much sugar, or you really get like brain fog, right? Like you feel like your memory is less. And so are there certain foods, and what's the role of diet in preventing like Alzheimer's, for example?
People often wonder, can a certain diet or specific foods help prevent cognitive decline? And I have to tell you that we don't currently have strong evidence to recommend a specific certain diet. But there are studies that show that what we eat affects the aging brain's ability to think and remember. And there is promising evidence for the Mediterranean diet and similar eating patterns. It has been shown that these eating patterns can induce cognitive benefits. And so it's really important to, I would say, in one sentence, I would say a heart healthy diet is a brain healthy diet. And I'd like to note here that despite the early findings for possible benefits for brain health, no vitamin or supplements have been proven to work in people. This is because the study so far has been too small or too short to be conclusive, but there's not strong evidence that supplements or vitamins can help make a difference.
Great, thank you so much. We're almost time. I just wanted to know if anyone had any questions that you want to kind of pose online. I see Dr. Touroutoglou online. Any questions from you, Adash?
No, thank you very much. I think it was a very interesting topic. I rarely get time to attend these, but this was like I told.
Off camera. Yeah, go ahead.
Can you hear me?
Oops. I think she went off camera again.
No, I'm here.
You're mute. I can't hear you.
I am actually not muted. Can you hear me now?
No sound.
Huh.
We can hear her.
Yes, I can.
Okay, everybody else can
It's
hear
okay.
me.
Yeah, no sound. I can't hear you, Anna.
Okay. No, I thought
Oh, you
it.
can, okay, go ahead. Go ahead. Yeah, sorry.
Yeah.
I put my sound off. Yeah, go ahead. Yeah, Arash.
Thank you, Esther. I think this was a great topic, and especially for me. I mean, I'm just in the age group where I want to become a super ager. I seem to be losing my mind all the time. I think sometimes I believe it's the stress, which kind of. So yeah, I worry for myself. I usually walk into my colleagues' rooms and say, I have no idea why I walked into your room. So I don't know if I'm really getting a dementia or Alzheimer's, or am I just stressed? So this was very interesting and good to hear. Thank you very much. I think I just need to go back to yoga, and I really appreciate your time, Dr. Alexandra, for giving us this time, and I'm sure all my colleagues online also appreciate that. Thank you, Esther, for bringing this to us.
Thanks so much, Arash.
Thank you very much. Thank you very much.
So I think we can close. I don't know if Dr. Alexandra, do you want to just say any last words, and also what do you anticipate, future studies that might be coming out soon, next results about from this study?
If I think I'd like to leave you with the knowledge that dementia is not inevitable, that having a super sharp, super young brain in older age is possible. I'd like also to urge you to have a healthy life and be ambitious when it comes to prevention. It's never too late in the life course to prevent dementia. Thank you very much, all of you, for your attention and your really interesting comments and questions.
Great, thank you so much. And I'm really sorry for the technical difficulties. We may just kind of re-record that section of the presentation so that it flows better for those who are not able to join us. But thank you very much, Dr. Alexandra. Really appreciate your time, and good luck for your future study. I think this is so important, and it's great that we now have all these imaging techniques that really allow us to see so much more and understand so much more about the brain. And we understand the connections now between the exercise and the brain and so many other things. They're all interconnected. So everyone, have a good day, and thank you for joining us, and hope we can all become super ages going forward. All right, thank you again, and we will be putting this online, and so you can also share with your colleagues if you're interested. Great, thank you, Dr. Alexandra.
Thank you. Thank you all.
To everybody. Take care.